But as an electronician, we embrace electrons, or our interest is to study the behavior of electrons and how we can use them to perform a function. So electrons must be flowing against the arrow, since the electron current flows from the negative terminal to the positive terminal of any power source. Back to our explanation, the emitter and the collector of an NPN transistor are made up with the N-type semiconductor material, and the base is made up of the P-type material. An NPN transistor is essentially two diodes connected back to each other. The diodes always point towards the N-type material. So here we have a typical diode, and this is the PN junction of this diode in green. Now the P part of the diode is called the anode, and the N-type region, or the N part, is known as the cathode. So when we connect the anode to a positive potential and the cathode to the negative potential, current would flow through the diode, and the diode would be in forward bias mode, which means the diode is going to be active with a voltage drop of about 0.6 to 0.7 volts for a silicon diode. Okay, now if we reverse the polarity of the power supply, let's say now we connect the positive terminal of the power source to the cathode of the diode and the negative terminal to the anode. So now in this condition, the diode will be in the reversed bias condition, and the diode is going to be off unless we exceed its maximum reverse voltage that it can handle. Therefore, it's very important to understand these terms: the forward bias and the reverse bias, because when solving problems related with transistors, you need to know if you are dealing with the active region, the cutoff region, or the saturation region of a transistor. Okay, now let's discuss the PNP type transistor. And the good news here is that it got the same three names for the leads as an NPN transistor. But with the PNP transistor, so everything here is in the reverse of this particular transistor. So instead of having two N-type materials in one P-type material like an NPN transistor, but we have the N-type material, which is the sandwich material between two pieces of P-type materials, where the base is made up of the N-type semiconductor. The emitter and the collector are made up of a P-type material. And the easy way to remember this type of transistor in any engineering drawing is that the arrow is pointing in from the circumference of the circle, or the perimeter. So the equivalent circuit symbol, or the three internal layers for the PNP transistor, is very similar to two diodes placed or connected face to each other. Let's see how we can draw the electrical or the schematic circuit symbols for an NPN and a PNP transistor, especially when drawing circuit diagrams. Let's start with the NPN transistor. With or without a circle, we can see the base, the collector, and the emitter. And remember that the emitter is the lead or the terminal that always have the arrow on it, whether the arrow is pointing inward or outward. For the NPN transistor, the arrow or the emitter points away from the center or not pointing in from the perimeter or the circumference of the circle. Whenever you see the arrow, that is the emitter part of the transistor. We have here the base and the collector, and the base is always in the middle. And now the other thing I want to point out to you is that generally 100% of the electron current flowing through the transistor will flow always through the emitter. Just roughly 98 to 99% is going to flow through the collector, and the remaining 1 to 2% left over is going to flow through the base of the transistor. So we can say a transistor is actually going to act like a current divider to a certain extent. Now let's talk about the PNP transistor schematic circuit diagram. The base, as you can see, is still going to be at the middle, but this time the emitter or the arrow is going to be pointing towards the center as opposed to NPN. Then this is the emitter. The collector will always be opposite to the emitter, same as for an NPN transistor. The arrow still points in the direction of whole flow or conventional current flow. Therefore, electron current must flow against the arrow. Same deal, 100% of the electron current will flow through the emitter, and 98 to 99% through the collector, and the remaining 1 to 2% is going to flow through the base of the transistor. Now for an NPN transistor, the emitter is simply usually connected to the ground or the GND. And for a PNP transistor, the collector is typically connected to the ground. The emitter of the PNP transistor will typically goes to the positive voltage or terminal of the power source, and the collector of the NPN transistor goes towards the positive of the voltage source. The base of an NPN transistor also goes to the positive voltage source. Meanwhile, for the PNP transistor, the base goes towards the ground. And we have to definitely want to connect a resistor to it, because we want the base current IB to be very, very small, because too much of base current can destroy the transistor, because this will allow a large collector current IC to flow through it, and that could cause it to overheat and damaging the component. Now let's see some things that you need to understand regarding these two types of transistors. Current flows into the base of an NPN transistor, whereas for the PNP transistor, it flows outward from the base. Note and keep in mind that the flow of conventional current is opposite to the direction of electron flow, as you can see. So for the NPN transistors, the conventional current flows from a high potential to a low potential, whereas electrons flows from a low potential to a high potential. So just keep that in mind, okay? The main reasons why we like to use conventional current when analyzing circuits involving transistors is that the direction of the emitter arrow tells you or tells us the direction of the emitter current IE and the type of BJT transistors we are dealing with. The collector current IC flows inward the NPN transistor, and the emitter current IE flows outward from the transistor in the direction of the emitter current. Now for the PNP transistor, current is going to flow from the positive potential to the ground. So IE is going to be the emitter current, and as you can see, it's in the direction of the arrow, same direction of the conventional current. The collector current IC is going to be flowing away from the PNP type transistor, and the base current IB flows away from the PNP transistor. Whereas in an NPN transistor, the base current IB flows into the transistor or into the base of the transistor. Now to round up this section, as we can see, the collector current IC flows towards the transistor in an NPN type device, while the PNP type devices, it flows away from it. But the direction of the arrow always tells you the direction of the emitter current, whether you are dealing with an NPN or a PNP transistor. So these two transistors are completely opposite to each other. Therefore, these are some basic things you will want to know about these two types of transistors. But for the most case, we are going to be paying our interest on the NPN transistor, which is the most used type as part of our circuit analysis. We are going to see some formulas that you will want to be familiar with when dealing with transistors. The first one is the collector current IC. This current, our collector current IC. And this collector current